Smith is our next speaker. He comes out of a lab, and we have two companies out of this lab. We don't have the professor. He almost came to this workshop. It was very, very close, I promise you. It was very, very close. So Professor Kripa Varanasi's lab is a very, very fertile lab at MIT for lots of different innovations. And I will let Dave Smith take the pitch there, but I will also say that yesterday he almost offered me a little job in his lab because of my baking skills. That's all I'll say. Apart from that, Liquiglide is a wonderful entrepreneurial venture that's now growing really, really fast. Are you going to show video?
Yes.
There is a video to be seen.
Thanks for setting this up. It's really an honor to be here in Silicon Valley, home of iconic American companies like Google and Facebook, Apple, and Intel that have really changed the way people relate to each other and how people work, how people find data. They've really changed the world. And it's an honor to be here to talk to you about Liquiglide's mission to revolutionize the way that people and industries move liquids. So throughout, all right, there we go. So I'm sure everyone's experienced the struggle they have in trying to get ketchup out of containers or mayonnaise out of containers. So we all know that liquids stick to surfaces. And throughout history, containers, processes, systems, and industries have been built on a paradigm where liquids stick to surfaces. And liquids are everywhere. And there's sticky liquids everywhere. There's consumer products, there's honey, there's lots of other things that we experience every day, like conditioners, lotions, and other materials that are hard to get out of their containers because they stick. All right, it's sticky, yeah. There's syrups, cough syrups, pharmaceuticals. All right. So there's paints, there's biologics, there's lots of sticky materials in oil and gas, and this is an industry where the economics of oil production are pretty much governed by how easy it is to get oil out of the ground. I mean, there's lots of heavy oils and bitumen that are extremely difficult to throw through pipes, and processes and for producing these materials are designed around the fact that liquids stick to surfaces and they're hard to flow. You can imagine a world where liquids don't stick to surfaces, so they no longer have to. So here's an example of Liquiglide on a ketchup bottle. And then it can even work for extremely sticky materials that are meant to be sticky. This is glue, and we have a license with Elmer's to get this into their glue bottles and expect to launch in 2017. This is an exciting opportunity for us. So this is one I'm really excited about because toothpaste has been in tubes for 30 years because, as you know, it's a really viscous material. It doesn't flow out of PET containers, which is why it's forced to be in tubes. It's the only way to get it all out. But that doesn't have to be the case anymore. Now toothpaste can be dispensed from a PET bottle, and you can get 100% of it out. It's much easier. And in my opinion, there's no reason to use tubes anymore. As I'll explain, liquid impregnated surfaces, that's what this technology is called. They can be made very economically. And this is made out of food, so the coating is completely safe. So it's really going to transform toothpaste packaging, and it's going to have a transformative effect on the packaging industry altogether. And also the oil and gas industry. So oil sticking to surfaces is a constant challenge in the industry. They're cleaning out tanks, and also, as I mentioned, viscous products, viscous oil-like materials are hard to pump through pipes, and it's very easy to flow viscous materials through a Liquiglide coated pipe. In fact, the more viscous it is, the bigger the benefit we have with a liquid impregnated surface. So let me explain how this works. So the way it works, you have a thin textured surface on your surface. Well, we first put down a thin textured surface, and we then put down a liquid which stays trapped within the textures of that surface. So it's like a thin sponge. And if we choose the right materials, as there is an algorithm, you can't just put any materials together, then you'll get this slippery effect. So there is a lot of science to this, but it's based on some pretty fundamental principles, and that's allowed us to develop a lot of design tools and build a database of materials that allows us to tailor coatings for different applications. So this is a patented technology. We've got 3 granted patents, another 3 allowed that will be granted soon, and over 100 pending in different countries throughout the world. So, and also mention, so I guess I never gave a brief history. So we were founded in 2012. Professor Varanasi and I co-founded this. I came out of we entered the MIT 100K competition and released this video of ketchup, emptying ketchup out of the bottles. And that's really what kicked us off. I guess that visual not only got us a lot of interest from packaging companies, but that's when we had oil companies coming to us. We had tons of applications in manufacturing. I'll talk about some soon. And it forced me to withdraw from MIT to start the company, because if I didn't start it then, the TLO probably would have licensed it out to a lot of the companies coming to the TLO. So it was the right time also when you have that much interest. I mean, that's the reason you go to MIT, right? So it's for what you're going to be able to do afterwards, and the opportunity was there. So we withdrew, and now I'll talk to you about why Liquiglide is going to make a big impact in manufacturing. I'll start with an example of the paint industry. So in the paint industry, or paint and coatings, there's about $130 billion of paint being produced. It's about 10 billion gallons of materials, and it's all mixed in tanks and pumped through pipes. And it's made in batches, and after each batch, you have to wash off all of the equipment because there's a layer of paint left on the surface. And that leads to an average of about 2% yield losses throughout the industry. And as you can see, with Liquiglide, you completely eliminate that yield loss. And there's I guess 99% reduction in that yield loss. And there's another benefit that's a little less obvious, is that since you don't have to wash with nearly as much water, there's much less water waste. In fact, water waste is really more of a concern and a problem for the industry, and it costs them more because this water is an environmental hazard. You can't just dump it. You have to pay environmental waste companies to come and remove the water at about $1.50 per gallon. So it's a big expense, and it's a pain for the industry, and not to mention all the labor that it takes to clean these tanks 4 times a day. So what does this add up to? Well, there's wasted materials that we are eliminating. About 200 million gallons of waste paint in the industry from just paint stuck to surfaces. And that's about $1 billion per year. And then there is waste water, as I mentioned. That's the next one. And there's about 1 billion gallons of wash water used throughout the industry, and $1.50 per gallon. That's $1.5 billion of waste. So it's not only a lot of wasted materials, but it's a big expense in the industry that we can remove. And I like to use this example because it's a case where Liquiglide was able to completely eliminate, or not was, will be able to completely eliminate all of the yield, all of the waste materials in an industry. I mean, the biggest sources of waste in an industry, almost all of the wasted paint, and almost all of the wastewater. So it's really it's a transformative impact in the industry. And you can imagine there's lots of things made in tanks and pumped through pipes like this. So it's easy to see how there will be much broader implications for this. So I'll talk a bit more about manufacturing before going on to the broader vision. But, so I mentioned basically that's one type of value that we can create. We can save waste, prevent, we could save yield losses and wash water usage in manufacturing. But also, it's much easier to move viscous materials through pipes. In fact, with toothpaste, we've measured it. We had a 10x reduction in the power required to pump toothpaste through a pipe. And so you can imagine now you could either, I guess one of the options you have is to go with much smaller, cheaper pumps. And that changes the economics of a lot of different processes, and it changes the whole way you can configure your systems. In some cases, you don't even need pumps. You can just let gravity drive the flow of these things, because there's really almost no friction between viscous liquids and a Liquiglide coated surface. So we're only beginning to imagine what some of how this is going to change industries. If now you can kind of redesign your systems, the cost structures are going to change completely, and new processes might become viable that weren't before this. So it's really exciting to have something that could have such a foundational impact. And so anyway, I'm from Dayton, Ohio, or a few miles from Dayton, Ohio. So as a kid, we always talked about the Wright brothers in school, and or the teachers would always talk to us about the Wright brothers. And but I used to always wonder, what the Wright brothers must have felt like the first time they saw the Wright Flyer take off. And like a few years ago, when we created this ketchup bottle and saw ketchup sliding out of the bottle, it sort of felt like a Kitty Hawk moment. We were onto something big. We felt like we were just beginning to understand what kind of impact it's going to have. And it's really exciting for me to have this opportunity really to create this impact. And it's Liquiglide's mission to make these coatings ubiquitous and to really revolutionize the way that we move liquids. So thank you.